Hi, hello friends. Welcome to T Academy. Now in this session we will continue our ESC Electrical 2019 solutions. Now in this session we will focus on the subject control system. In the control system there are around 12 questions are asked in the ESC examination. Okay, we will start the first question here. So before going to start this session, I would like to thank you for all your subscriptions and comments here. And those who are not subscribed to my channel, please subscribe to my channel for more updates. Okay, let's start the question here. The first question here it is, a transfer function g of s is equal to 1 minus st divided by 1 plus st has a phase angle of minus 2 tan inversion of omega t, which varies from 0 to 180, 0 to minus 180 as omega is increased from 0 to infinity. It is the transfer function for. Now here they given a transfer function is g of s is equal to 1 minus st divided by 1 plus st. Suppose if we draw the pole 0 diagram of this transfer function. So first we will draw the pole 0 diagram here, how it is see. So if we take this pole 0 diagram and we will see the zeros. So first we will write this g open loop transfer function into a standard function. So g of s is equal to we will make a t common here. So t common means 1 by t minus s divided by again here 1 by t plus s here. Now t gets cancelled. So from this equation we will write 1 by t minus s divided by 1 by t plus s. So this is in standard function here. Now we will get the poles and zeros. What are the poles here? So poles are nothing but s is equal to minus 1 by tau is the one pole, and there is a 1 0 here. S is equal to plus 1 by tau. If we draw this on a pole 0 diagram, so here we have imaginary axis, we can call it j omega axis, and here is a real axis or gamma axis. So this will be real here. So real positive here and real negative here. Okay. Now if we draw this s plane here, the 0 will be here somewhere else is minus 1 by t, and pole will be here minus 1 by t, and 0 here will be here, it is 1 by tau here. Okay. Now if among the transfer functions the answer is alpha system. I will give why it is a reason why it is alpha system here. So the characteristics of, let's say, all pass system. The characteristic of all pass system is, first one it says that the poles should lie in the left half of the S plane, and 0 should lie in the right half of the S plane. So poles should lie in left half of S plane and zeros should lie in right half of the S plane. Okay, so these two are satisfies this condition. And the second condition is the poles and zeros are symmetric in nature. The poles and zeros are symmetric. So symmetric means the pole value and zero value both should be same. So both these two are symmetric and they are lying in the symmetric here like this. So these two conditions satisfied means the system is said to be all pass system. So the answer here it is a all pass system here. Okay, hope you understand this question. We will move to the next question here. The second question here it is, the open loop and closed loop transfer functions of systems are given by, so g of s is equal to k divided by j omega t plus 1, and g of s is equal to k divided by 1 plus k plus j omega tc or tau c plus 1. So it's a closed loop system. The ratio of bandwidth of closed loop system to open loop system is, now here first we will take the basic formula here it is, that is we know that the gain into bandwidth is nothing but a constant. So this is the formula you need to remember to solve this answer here. Okay, so note it down. Gain into bandwidth is nothing but a constant. Now first for open loop system, what is a gain? So open loop system, gain of open loop system is, let it say k, and the gain of closed loop system is k divided by 1 plus k. Now we will take this gain, we will find the bandwidth value. Okay, now here the bandwidth of, let's say, closed loop system divided by bandwidth of open loop system into the gain of closed loop system divided by the gain of open loop system is equal to, so let's say 1. Okay, now from this, bandwidth of closed loop system divided by bandwidth of open loop system is nothing but gain of open loop system divided by gain of closed loop system. So gain of open loop system is a k divided by, so gain, okay, sorry, so here it is a closed loop system by open loop system, sorry. So gain of closed loop system is k divided by okay, let me correct here. So open loop system, I'll write it again here. So it is nothing but the gain of open loop system divided by the gain of closed loop system. So gain of open loop system is what? K divided by gain of closed loop system is k divided by k plus 1. Okay, now k gets cancelled. We need the ratio of bandwidth of closed loop system divided by bandwidth of open loop system is equal to, so it is simply k plus 1. Now question is, the ratio of the bandwidth of closed loop to open loop system is, it is nothing but 1 plus k. So B is the right answer for this question. Okay, we'll move to the next question. Now the system sensitivity of open loop and closed loop systems are respectively. So sensitivity is nothing but it's a change in output divided by change in input here. For example, generally you can take, it's a open loop transfer function or open loop system. So open loop system is there, the input if you are giving, the output you will get here, it is directly. Now if you change the input, automatically output also will change. Sensitivity is nothing defined as change in output divided by change in input. Now if you are changing input, automatically output will change, so the ratio will be 1. Okay, suppose in a closed loop system, the input if you are changing, the output will be remain constant, it will not change. Okay, so from the among the options you can see it is A is the right option for this question. So it is in the closed loop system 1 plus GH is there. Okay, so G is a forward path gain, H is a feedback. Okay, now we'll move to the next question here. The steady state error for type 1 system to a unit step input. Okay, so first for this one we will draw a tabular column here. So where we will write the ESS, that is steady state error, and here we have write step, ramp and parabola. Okay, so steady error for it is ESS, and it is a type here. So type 0, 1, 2, 3. Okay, so type 0 for step function 1 by 1 plus k p, and this will be infinity, 0, 1 by 1 kp, kv, infinity, 0, 0, 1 by k acceleration ka, and this will be 0 here. Now the steady state error of a type 1 system. So type 1 means type 1 here to a step input. Step input is what is the response here? It is 0. So ESS is going to be 0 here. So remember this tabular column, it's very very important, and you can expect one question from this tabular column itself. Okay, now note it down in your notes. We'll move to the next question. The direction of the net encirclements of the real imaginary plane in a Nyquist plot for the system to be stable. So for the system to be stable, it is counterclockwise direction. So it says the number of encirclements. Okay, if the number of encirclements are there, then the system is said to be stable. Okay, next question. A unity negative feedback control system has an open loop transfer function g of s is equal to k into s plus 1 into s plus 2 divided by s plus 0.1 s minus 1. The range of values of k for which the closed loop system is stable will be. So to solve this question, we will take the help of characteristic equation, so which says that 1 plus g of s. So unity feedback system is h of s is going to be 1 is equal to 0. We can call this one as a characteristic equation. Now by taking this formula here, 1 plus k into s plus 1 into s plus 2 divided by s plus 0.1 into s minus 1 will be equal to 0. Okay, so by solving this equation you can get s square into 1 plus k plus s into 3k minus 0.9 plus 2k minus 0.1 is equal to 0. Now for the stability, the coefficients must be positive for second order system. So coefficients must be here means first one it is 1 plus k is equal to 0. So k is equal to be minus 1. Okay, and next one 3k minus 9. So 3k minus 0.9 is equal to 0. So k is equal to, so it is 0.3. And 2k minus 0.1 is equal to 0. So k is equal to 0.1 divided by 2, 0.05. Now these coefficients must be greater than 0 means the k value should be more than these values, should be positive here. Now suppose for example here in this case I will take this should be positive means 3 into some value should be which is more than 0.3, let's say 0.4 minus 0.9. so how much it is? So 3 into 0.1, 0.2 minus 0.9 is 0.3, will get it here, like that positive value should be there. So because of this reason the k value should be greater than 0.3, not less than 0.3. so answer here it is k is greater than 0.3. option B is the right answer for this question here. We'll next move. Now it is from the compensators. The lag system of a lag lead compensator has a one pole and one zero, has a one pole and one zero. The pole and zeros are, so for this we will understand, for a lead compensator, already we discussed in the previous videos, for a lead compensators the zero will be nearer to origin. For a lag compensator pole will be nearer to origin, but the question is it is a lag lead compensator. So for lag lead compensators we will draw this diagram here. So first we will draw lag means pole will be here, 0 will be here. Now for lead 0 will be here and a pole will be here. Now so from this the poles and zeros, so poles and zeros should be it should be real, yes, real value, and the pole is set to right of zeros. So pole is set to right side of 0. So this is if you are seeing, so this is the right side and this will be left side. So pole should be the poles should be right. So if we compare here 0 here, so the pole is to the right side. Okay, so the answer here it is the real and the pole is to the right of the 0. So here we will see. Okay, we'll move to the next question. A system with characteristic equation f of s is equal to s power 4 plus 6s cube plus 23s square plus 40s plus 50 will have closed loop poles such that all the poles lie in the left half of the s-plane and no pole lies on the imaginary axis. Two poles lies symmetrically on the imaginary axis of the s-plane. All four poles lie on the imaginary axis of the s-plane. All the four poles lie in the right half of the s-plane. So all the for getting this answer, first we will take the help of RH tabulation. So by using this RH tabulation, first we will write from the equation s power 4 s cube s square s power 1 s power 0. Now first we will take the coefficients 1, 23 and it is 50, and similarly second row is 6, 40, 0, and if you cross multiply, I will show you one calculation here. 6 into 23 minus 40 into 1 divided by 6. So you will get the answer as 16.33 here. So like this I will write 16.33 and here it is 50, 0. Now similarly 16.33 into 40 minus 6 into 50 divided by 16.33, you will get it as 21.6300 will get, and 50 0 0 will get. Now here there is no sign change. No sign change means all the poles lies on the left half of the S plane. So because it is because of no sign change present here in any column. So here positive, 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 positive. Okay. So the answer is all the poles lie in the left half of the S plane, and no pole lie on the imaginary axis is the right answer for this question. So this kind of questions are important for GATE exam as well as any PSUs. These are the standard questions which may appear in any examination. Okay. So next question we will see. A unity feedback negative system has an open loop transfer function g of s is equal to k divided by s into s plus 2. The closed loop system has a steady state unit ramp error of 0.1. 0.1 steady state error is a 0.1 is given. The value of gain k should be, now here they given ESS is equal to 0.1 and we need to find the ramp. Now in the previous questions we have seen this steady state error for ramp input. So it is 1 by kp. So kp, what is a kp? So kp is equal to limit s tends to 0 s into g of s, which is nothing but limit s tends to 0 s into g of s, nothing but k divided by s into s plus 2. S gets cancelled. It is nothing but when you substitute s is equal to 0, 1 by s plus 2, s is 0 means k divided by 0 plus 2 means k by 2. So that's what we got here. Now we substitute here. So let me take equation number 1, equation number 2. Now if we substitute equation 2 in equation 1, ESS is equal to 1 by k by 2. We'll get it. ESS value is already we know, it's a 0.1 is equal to k by 2, 1 by k by 2. Now k by 2 is equal to 1 by 0.1, that implies k is equal to 10. That implies we can write as k is equal to 20. The right answer for this question is A is nothing but the right option here. Okay, we'll move to next question. The transfer function of a discrete time system derived from the state model is given by, it's a simple direct forward question. The transfer function is equal to C into Si minus A inverse into B plus D here. So here actually mistake is there, so it is Si here. So C into Si minus A into inverse into B plus D. So this question is from the state space analysis. It's a direct forward question. So answer here it is, so C is into Si minus A inverse into B plus D. So A is the right option. Next question. The closed loop response of a system subjected to a unit step input is C of t is equal to 1 plus 0.2 into e power minus 60 into t minus 1.2 into e power minus 10t. The expression for the closed loop transfer function is, suppose friends, if you are solving this question with the help of the Laplace transformation, you will get almost 2 or 3 pages of solution. So the shortcut here, what it is, the C of t is equal to 1, so steady state value is there. So 0.2 plus e power minus 60 into t minus 1.2 into e power minus 10t is there. Now the steady state value of any system of transfer function is 1, means it going to match the answer. So the answer here it is going to be B here. Okay, now how will this check? Now check the operation here, so which has a steady state value. So limit s tends to 0, the input is what? The input is step input, so s into g of s. So g of s, what is you have to take? So g of s is, we don't know. Let me take B option here. S into g of s means it is multiplied with the input here, so into 1 by s, so it is the step input into 600 divided by s plus 60 into s plus 10. If you substitute s is equal to 0, 600 divided by 60 into 10, it is going to be 1. Now if you want to cross check any other option, you can cross check. For example, check C. So C is a limit s tends to 0, okay, s into 1 by s into g of s means 60 divided by s plus 60 into s plus 10. So 60 divided by 600, it is nothing but 0.1. So 0.1 steady state value, but here his answer is 1. So answer is B is the right option. Okay, and the next question, if it is possible to transfer the system state xt naught to any desired state x of t in a specified finite time by a control vector u of t, then the system is said to be. I will repeat again. If it is possible to transfer the system state xt naught to any desired state xt in a specified finite time by a control vector u of t, then the system is said to be completely state control system. So completely state controllable system. So thank you friends, thanks for watching my video. If you like my video, please subscribe, share and comment. Okay, thank you, have a nice day.